Hi everyone, welcome to our 60 DevOps course. If you are new here, don't forget to subscribe. I share DevOps and cloud tutorials packed with real hands-on projects to boost your skills first. So today is our class topic is why is scaling. So scaling is the one of the most important feature in Kubernetes. So there is basically two ways we can scale our resources. So let me explain with an example, then that will better for understanding. So when using any pod, so like this is a pod. So when this resource is fulfilled, when a user are requesting too much to any server, so then that resource will be fulfilled. Like when this resource is using 100%, so then this resource or this server will not capable to serve any data to the user. So then basically it will deploy same server horizontally with another. So like this is a 8 GB server, so system will deploy another server like 8 GB. So if this one also fulfilled, then it will deploy another server. So this way basically our system will be increasing horizontally this way, so one by one. That means like a resource will be increase with same type of server. Like if this is two core server and 8 GB RAM, then another server will also deploy with the same configuration, 2 core and 8 GB. So this is basically horizontal. So in the below image you can basically understand properly. So you can see this is 2 GB server. So when horizontally deploy, it will deploy same configuration server 2 GB and this one same 2 GB. So it will horizontally increase one by one. But when we are using this is 2 GB server, if we want to increase the memory from 2 GB to 4 GB, then we need to go this way. So 2 GB, then 4 GB, then if you go for 8 GB. So then you can see this is up from vertically. So one is the main disadvantage of the vertical. We already know, when we update any resources in our server, like from CPU 2 core to 4 core or RAM 4 GB to 8 GB, then we need to power up the server. Then we can basically increase the resources. So that way basically we have a downtime. So normally in the production level we are not using vertical scaling. We normally using basically horizontal scaling. And another scaling is when we are deploying any pod in Kubernetes. Here is a one pod, not pod, a workspace basically. Let me go the documentation first, then I will come back here again. So why scaling? So scaling is important for high traffic redundancy. Okay, so we already told scaling is need because when our resource will be fulfilled, then it will generate another server, then user will don't get any problem. So there is basically scaling two way. We can do basically manually and automatically. Okay, so this scaling we can do manually by running any command, or it will done by automatically. So in this Kubernetes scaling and auto scaling, basically there is three way basically. So horizontal scaling, we already see. When our CPU or memory uses will be high, it will increase the server with the same type of server, and it will increase horizontally. And when resource will limit vertically, that means our server power or resource power will be going increase from 2 CPU to 4 core CPU, or 8 GB RAM to 4 GB RAM. This is called vertical autoscaler, and this way basically we have to set some downtime. In another way, basically cluster autoscaling. So scale the number of worker nodes in the cluster when pods can't be scheduled due to insufficient resources. Okay, so this one I was explaining now. So when Kubernetes deploy any pods to a server, that server basically is a worker node. This is a worker node. So this worker node is a server. So this server has 8 GB RAM. Okay, now one node is master node. So K8 master node will basically monitor or deploy everything. So we already know in the architecture class or like how this work. So like in the like worker node, like this is worker node is like server. So every server has a like resource limit. So like if we have a pod deployed, but like this pod is like take 2 GB RAM. Okay, so we deploy another pod is take 2 GB RAM. So like deploy another pod 2 GB RAM, another is 2 GB RAM. So 8 GB is fulfilled. So if now want to Kubernetes like increase the resources or deploy any another pod, then basically in this server there is no resource limit. That's why Kubernetes want to deploy another cluster or worker node, then it need to deploy that. So it will deploy another server or cluster like W2. So in the like fifth container or pod will be deployed here. Okay, so 2 GB. Okay, so this is the call basically cluster. So it will like deploy or increase another server or cluster. So this is called CA. So that's the thing we like saw in the documentation. So go back to documentation. So you can see cluster autoscaler or CA scale the number of worker nodes in the cluster when pods can be scheduled due to insufficient resources. So when like Kubernetes try to deploy pod to that server, then Kubernetes find that that server has not enough resources to deploy that container to that server. So then Kubernetes basically will deploy another worker node, and that pod will be deployed to the new worker. So this is called basically cluster autoscaler. So this is the thing, 3 main autoscaling option in the Kubernetes. So now basically we will see this like manual scaling first, then we will see the auto scaling, how that work. So first I will deploy and show you the like hands-on with the manual way. So we'll do this manual option by running the like command. Okay, so let me go to the terminal now. So here is the terminal. So like let me run this command to like deploy a HTTP image. So like do one thing for like properly see. Okay, so now we need to like run this command kubectl create deployment. So it will create a deployment, name would be my app, and it will use the image HTTP. So let me grab that command and paste it here. So you can see the deployment is created. So if you want to see the deployment, just kubectl get deployment. So you can see one deployment is created. So now like we already know when we create any deployment in Kubernetes, it was not able to exit from the outside. So we need to need a service. So we already see how to create a service by manifest file. Now I will say like how we can basically create the service by a running command. So this command will basically create a service. So we are using kubectl exports deployment. The name of the deployment is my app, and the type of is node port. So we already know when we are like try to expose our Kubernetes pod in the local, we use basically node port. So it will create a service also. Now if you want to see kubectl get all, you can see our one pod is already created and it's running, and one service. So this one is minikube service, this one is our service, my app, and one deployment and one replica set. Okay, so now if you want to like see this website, we need to like go to the IP and use this port, but I'm using in the WSL, so I need to use minikube service. So there's where basically I can use my local host IP. So for getting this service, if I open the service in this terminal, then it will be occupied. So let me like open this service in different terminal. So just make sure your service name is my app. Okay, so let me copy that one. So here is the service. So we already know kubectl minikube service, then the service name, then dash URL. So it will give you the URL. You can see like this IP. You can get the IP. So let me grab that. I need to open it here. So you can see it works. That means Apache default website is showing the website. So now we already see we are using only one pod. Now if we want to make it when are using more resources, then we need more pod. So we can do this thing by manually. So for running increasing the pod 1 to 3, we used to 3. So how many pod you need to deploy? You need to make sure you put it here. So here I want to 3 pods, so I need to make sure 3 replicas. So kubectl scale deployment, then the deployment name is my app, and how many replicas you need to mention that one. So it will basically increase the pod. If you go to the let me give ctl get all. So you can see extra 3 pod is creating, one is already running 7 seconds 77. So let me try again. So you can see all pod are running. Now if you want to browse the site, you can see this website is properly running. Now this website is serving from these 3 pods. Okay, so these way basically we can scale our deployment manually. So we need to do this thing basically automatically. And when we locally when we are testing, that time basically we are using this type of ad hoc command, or we just temporarily increase the pod or decrease the pod. Okay, so which command I used here, I already put in this documentation. So now I want to show you if our website version is changing. Now we are using v1, so if we are going to new version v2, and if we have suddenly found any problem in that new version, how we can go back to the old version, that thing I will show. This thing basically in the Kubernetes basically telling rolling update. So I will put some documentation here. So gradually replacement of old pods with the new pods. So it will be if you have 3 pods here, so it will basically create a new pod and deploy the new image with that pod. If that image is working properly and a pod is running fine, then it will delete one old pod. Same basically it will create another, then delete that one and create another and delete that one. That's why it's still gradual replacement. So it will do one by one and ensure for this it will zero downtime. So user will don't face any downtime issue. So basically user will don't get any where they will understand what's going on the backside. So they didn't see anything basically. So now we are doing this thing in the hands-on demo. So I put something before update the image, we need to know the container name by using the following command. When you are running this thing, we need to know what is the container name and what is the image name, because when I update the image, we need that command. Okay, so if you want to see the deployment details, we already know we are using kubectl, then describe, then our deployment name is my app. So if you type this one, kubectl describe, we need to run the deployment. So we need to make sure what type of this. So it is deployment, so we need to mention it deployment. So if you run this command, it will basically tell you everything. So from this thing you can see the image container name is using HTTPD, and also the name of this my app. So if you want to grab this thing when you are using production level, there is lots of thing in here. So then basically you are using this simple command. So we need to grab image. So then you can see the which image basically is using. So now basically we need also the if you want to see the container name, we can do another command I put it here, kubectl get deployment my app. Then that deployment file you can get a YAML output. So dash output, so dash o YML. So if you run that command, let me show you the thing kubectl get deployment then your deployment name is my app. Then if you type -o-y, you can see what is showing. Grab wise my app is missing. You can see these like container we can get a YAML format, so we can basically take that command and take it a different file also. But now basically we are trying to get from this all file. I need to show where we use the name, because we need the container name and the image name. So like same way basically we are grep and name. So basically it will show where it using name. So name is my app, name is HTTP. So where is used name, that thing is showing here. So basically I try to show you, because this thing basically when you're doing some R&D we need that command. So I think it is a good way to show you also. I can see you the like what command I need to use, but I try to like show you which you like face in the real world scenario. So for you like update the image, the simple command is kubectl set image and deployment name, then what image you want to like update. So let me copy that one, just show you this thing easy way. So kubectl set image, we want to update the image, then which deployment image you need to update, you need to name that one. You can use like deployment this way, or also you can use this way, both way you can use. Then the image name we're using HTTPD, we already saw how we can get that image. So HTTPD image name, then we need to use that image name, which one we going to use. This is like I have simple image in my Docker personal Docker Hub registry. In this registry this is a simple image just showing a message. So I want to like showing you the like how we like if you want to change your version, then what's the way we can do, and if you face any issue, then how you can go back to the show. I am using that image, so you can get it from this URL. So this is the image, so let me enter that one. Let me show the documentation also, because some command you need here. So like this command you need to like need later. So let me enter that one. So you can see image is updated. So if you see kubectl get all, you can see like one container is creating and another one is terminating. So these way basically it will create 3 container and delete 3 old container. So that's why I want to show you. You can see 3 container is running now, and all are just created right now. 9 second, 18 second, 13 second, and in the replica set it will basically do that way, like create one container here this new replica set. Basically how many replica set you have, like here is 3 replica set with 3 ports. So that's why it create a new replica set with 3 port. So and it will update 1 port, and if everything is fine, then it will delete the old from that replica set. These are basically 1 2 3, it will do one by one. So in the old replica set there is no pod is running now, all pod are running in the new replica set. So now if you want to like go back to URL, you can see this website is the new one will be showing. You can see now it's showing that different website with just Siddiqui. So these way basically we can update any new image. Now if we find anything wrong in that image, so how we can update the image, we just use kubectl rollout undo then the deployment name. So let me copy that one, just go for quick way. So copy that one. So now if you want to see the kubectl rollout status, you can see it will be going to update it one by one. You can see it will update 1, then update 2, then update 3. So you can see all 3 containers is running. When this is basically simple website, that's why it's going so quickly, but in production level it will take a little bit more time, and you can see one by one, and that time like container will be also more, so it will take a little bit more time. So all update is going back to our previous one. So if you go to now website, it will show the old one. You can see it is go back to the old one. And now if you want to see kubectl get all, you can see the new replica set all pod is now 000, and the previous old one is going back to 333, and it will create the 3 new containers. So now if there is 3 command we are using, like we can see the status. We already see the status command, how the deployment is going, and the history also one command like kubectl rollout. You can see like when we deployed that one was 1. Now we change the image to that one, Rajiv Siddiqui web-23, that will create the 2. Now it go back to the previous one, that's why it's 3. So old one is going down, and it will basically 3. So that's why he's showing 3. If we want to choose another one image, then it will be like 4. So these are basically we are doing like update or anything, and we can also doing like scaling in our pod. So this is basically manual way. Now in the next view I will show you like basically how we can do this thing automatically. So before do that, let me down everything. So kubectl delete deployment. So our deployment name is my app, so it will delete the deployment. We also need to delete the service also, service, and our service name is I think same, my app, same. So don't need to change that one. So now everything is down, kubectl get all. We can see nothing is running now. So let me clear the screen. So now like I will show you how this thing will done automatically, and this is called auto scaling. This is in different document. Let me go to that document. So like when you get this documentation, I will add that 2 documents in single file, so you can get it everything in that file. Okay, so let me go to the auto scaling section. So we already know how to like way we can scaling our like pods. One is manually and one is auto scaling. So there is 3 way how to scale. You already told in the before in the class. There is HPA, then one is VPA, is like a vertical pod. HPA is horizontal pod scaling, and one is cluster pod scaling. So now let me tell you the demo. So in my local PC I have already installed the matrix service. So in your case it will not there. So for installing that one, you just run the previous command. So when you run that command, you can get this in your PC. So if you want to see this, just go to copy that one, get deployment. So you can see one matrix server is running there. It will basically monitoring all our pods, and if our pod usage is going so high, then it will tell auto scaling to increase the pod or decrease the pod if our usage is going down. So now I will show this demo in like a manual way, auto scaling, but in manual way. Like in the real world, we have another way you can also do that thing. I also created video. You can get it from the description. And for this demo, I need to create a simple application. So want to show you the proper way how this thing is work. So basically we are using just a simple Node.js app, and we will create a simple Node.js file where it will show hello from Kubernetes Auto Scaling. Okay, let me create that file. So get app.js. So now I need to create a Docker file. Docker file, basically it will take the Node.js image, then it will say the working directory user SRC app, then it will copy this file what I created here to the Docker container. Then it will run the npm init and npm install express. It will basically command for using Node.js and express, and it will express 800 port. Then the file will be run by this command. So we already know everything in the Docker section. We have already discussed in the Docker module. So let me create that one now. Okay, so both file is created now. So Docker file and app.js. Now by this Docker file, we will create a image and upload it in our Docker Hub registry. So we already know how to create the build the image. So Docker build -t we need to put our Docker Hub registry name. So DevOps steps. Then like what name you want to put, like let me put ASC 2025. Then our Docker file location is here, that's why I need to put dot here. So it will create a like image by using that Docker file, and now the image is available in our locally. So you can see not this one ASC 2025 is created. So now we need to push that image to our repository. So Docker push, and the image name so it will basically push the image in our Docker Hub. Now basically after pushing the image, we'll create a deployment file by using this image. So it is going to uploading, it will take a little bit time. So let me explain the deployment file. So we already know how to create a deployment file. So in this deployment file, we are giving this deployment name it or auto scale demo. First we are using one replica set, that means one pod will be running, and the selector using same app auto scale demo. In the template section, we use the same label, so which container it auto scale, that will monitor the deployment or work with that pods only. In the container section, we are using which image you need to create, so it will take the image, so which image you are using. So in my case, our Docker Hub registry name is DevOps step, then slash your image net, which right now we are creating ASC 2025, that will be here, and container port is 800. Already know when the image will be created. And then resource, this section is basically new. So for using any pod, we need to limit that one, or we need to tell Kubernetes, when you are creating a pod, that pod maximum use this type of limit. So it will basically request 100 CPU, and its limit is go up to 200 M. So we can also use in the memory also. So in this demo, we just are using a CPU. We can do basically other metrics also, be how many heat this server is getting. So you can also customize, but most of the time we are using CPU and the memory for monitoring the pod. Then the service is same. Just create a service, give the service name same autoscale demo. Then it will expose 8080 port, and it will the cluster IP. So let me create that file first. Copy. So cat. So we need to make a little bit change. So we are changing here. So we are using DevOps steps slash ASC 2025. I think we use that image. ASC 2025 DevOps steps. Okay, rest of the thing is same. So let me I want to make sure that image was ASC 2025. ASC 2025. Okay, so image name is right. Now basically I will create a deployment. We also need to deploy one thing new. I'll show that one. Now first we deploy the file. So kubectl fly -f, our deployment file is named .deploy. Then kubectl get all. You can see one pod is running and service also running. All give the same name, auto scale demo and deployment and replica set. Okay, Now we need to create a HPA, which is Horizontal Pod Autoscaler, that will basically monitor the pod. If pod usage is going high, then it will increase more pod, and if is usage going down, then it will destroy that pod or downgrade the pod. Okay, so now I will basically create the HPA manually, and I already told you I did the same thing in manifest file. You can get it from that documentation, that video link. There basically I used auto scaling HPA option by creating manifest file, and most of the time in the production level we are using that one, but I want to show you both way how we can use manually and how can we use by manifest file. So basically it's same. Let me copy that command. Let me clear that screen first. Okay, so basically it will create a kubectl auto scale deployment. We give the deployment name, then basically we are telling CPU percentage 50. So when the CPU percentage is going more than 50, it will create a new pod. Okay, and minimum would be 1 and maximum it can go up to 5. So it will increase the pod maximum 5. So after 5 it will not have any option to increase the pod, even though pod uses is more. Okay, so now let me create that one, kubectl autoscale deployment, that command. So now if you type kubectl get HPA, you can see the HPA is created. Here is your unknown. It will take a little bit time to get, but initially it will show you 0 because we are not using that much, and we can also get everything, kubectl get all. We already know that. In the bottom we can see the HPA is created. Now it is showing 0. So our pod is almost nothing using, so that's why it is showing 0. But when this using is going high, it will create more pod, and if skin is going bigger, then you can basically understand the proper way. But let me explain that one. So initially it's 1, and maximum it can up 5. Running is 1. The deployment is happening 23 seconds. This thing is telling is here. So now let me create one. Before that, I want to show you another thing. We're running service here. We want to use this command kubectl K8s. Then we can see how many pod is running. So when pod is increasing, we can get it from here. So, and we also create a script. I gave that script which will basically request that pod frequently. Then this pod is going high, then basically it will create a new pod. So let me do the thing. So kubectl run, it will create a pod basically, and we run a command in that pod. So do that thing different terminal. So kubectl run, we already know how to create a pod. Then interact mode, then tty, pod name is load balancer, then we image using busybox, then we are just logging that container. That's why using bin and sh shell. So it will create a container. We will get inside the container. So we already see we are inside the container. Now in the container I will run that command. It's just loop command where I will browse that website continuously. So while true is a command do get wget, and basically get that container name, but it will basically browsing that thing continuously. And what message we can see it here. Let me enter that one, and you can see that message we are putting, that is showing here continuously. Okay, now basically in the section you can see the new container is running, which was basically generating the script for going to increase the uses of that pod. So you can see these SPA will be going to increase. It will take a little bit time. So let me go back to the documentation also. So which command I use, that I also put it here. So you can use that command also. You kubectl get HPA, watch, then it will show the HPA frequent current option. Same way you can use kubectl get pods -- watch. You can also see the new pod is running, and what this thing will do, like you will see replicas increase from 1 to up to 5 when load is high, and when load is decreased, replica scale back down automatically. So we need to basically wait. You can see it's going to 118%. So now you can see there's basically 2 more pod is created. One this 2 is 24 seconds. The new pod is running, and it's 1 by 1 is running. And if you want to see, you can see 3 pod is running, and it's just 41 seconds. And basically after a few minutes more, it will increase more because using is going high. Now if you want to like see that service, I think we didn't use that one. It's different service, I think. So Minikube, yeah, it's different service, and our service name was this one. So let me grab that, put it different. Oh, I have to only copy the full thing. You can see that message is showing now properly. So if you run refresh, you can see our website is serving smoothly. So now go back to documentation, and here let me go up arrow. So it's increasing, and after some time basically it will scale up to 5. So keep it here, and let me see. You can see it is created 2 more pod because our usage is going high. So same way basically it will serve the website from this 5 pod. Now its limit is done. Now no pod can be run because we give them limit is 5. So now we need to decrease the uses. So for that we need to stop that script. So we need to type Control C. So it will script that script. So now it will take some time to downgrade the pod. So it will take some time, and gradually it will down when his CPU is going down gradually 0. Then basically we can see the here is showing only 1 pod, but it will take around 4 to 5 minutes. And in the auto scaling section, you can see our 5 pod is running, and our limit is 5, and it will deploying 6 minutes something seconds. So basically it will take a little bit time, but I want to show you how to do this thing. So let me pause this video for 5 minutes, and then come back after 5 minutes, and we can see the CPU will be 0, and pod is also going to showing 1. Okay, so let me pause this video. So after waiting 5 minutes, you can see now only 1 container is running, and that one is the script generator container. So our main container is that one, and you go to the here. So if you type kubectl get all, then you can see our usage is going 0, which was previously 82% before I pause the video, and you can see only 1 container is running and everything is working fine. And if you go to the website, that will also serve the data properly. Okay, so basically that's way auto scaling is happening. So everything I use in this demo, all command will get in this documentation. So that's all for today's video, and in the next video I will discuss any different topics of Kubernetes. So if you found this video is helpful, don't forget to like, share and subscribe to get notified when I upload the next one. Best of luck. Bye.